So another way to use z-scores is just to compare things from different distributions. It allows us to put everything on the same scale, essentially. So let's just look at this first example. So your friend is also taking stats. They score an 87 on the first exam while you score an 83. So if we were to just stop right here, it looks like your friend did better, right? They scored 4 points higher than you. But you know some statistics, and you know that I tend to have tough tests. So you realize his exam was easier. Their class average was an 80, and our class average was a 70. So he only scored, what, 7 points higher? Well, you scored a full 13 points higher. So it looks like you did better, right? But that's where the standard deviation matters, how spread out everything was. So his class had a standard deviation of 5, while yours had a standard deviation of 10. So this time I'm going to use the empirical rule a little bit just to give us, I'm not going to put out the percentages, but just to give us a little drawing of what's going on here. So we'll go ahead and assume we have little normal distributions here, which is probably untrue, but it's going to make our drawings a lot easier. So this is your friend. This is you in terms of the classes. In your friend's class, like we said, the average was an 80. That is not 80, that's 81. I don't understand what happens in my brain sometimes. And then we could do those 3 standard deviations above and below. So 85, 90, 95. And your friend scored an 87. So they're right above the 85 mark, right? Not quite halfway between the 85 and the 90. Now, in your class, the average was a 70. But the standard deviation was a 10, so there's a lot more spread. And your score was an 83. So you're also right above that first standard deviation, but 83 is a heck of a lot closer to 80 than it is to 90. So it looks like you might have done worse, and that's where z-scores would help us determine this. So the z-scores, again, we're going to put in your friend's score, which is an 87. Subtract, ooh, I wanted to change colors, and I did not. Subtract off the mean and divide by our standard deviation. So we're going to get 7 minus 90. What? I don't know. 7 divided by 5. I was like, the reason I immediately knew I was wrong is because I knew that your friend scored above average. The z-score, remember, is 1 point something, just based on this drawing, because he's 1 standard deviation plus a little bit more above the, whatever the heck that's called. Yeah, can't even do it. My brain isn't working. So 1.4. Whereas for you, the z-score is, we've got that 83 and minus the 80 divided by 10. Oh my god. Why am I writing in rent? It's because the means are like not even looking central on these things because I do such a bad job of drawing my curves. The mean is 70. So in this case, we end up with a 1.3. So your friend barely scored better than you. So your friend scored better relative to his class. So hopefully this didn't seem that bad minus my not writing in the right mean on either calculation. I want you to try the next example on your own. Make sure you got this because this is a very, very common test question.